Hello students, welcome to Netview Academy. In this lesson, you will learn modular arithmetic, a common topic in WAEC and other exams. By the end of this video, you will understand remainders, congruency, and how to solve modular arithmetic questions easily. Keep watching. Arithmetic deals with remainders after division. For example, when 17 is divided by 5, the remainder is 2. When we divide 17 by 5, the remainder is 2. And we write it this way. So we write it as 17 divided by 2 is equal to, 17 divided by 5. 17 divided by 5 is 3. So 17 divided by 5 is 3. 3 into 15 is 3. So 3 remainder let me just use R to represent remainder. So 17 divided by 5 is 3, remainder 2. So this is represented as, in modular arithmetic, it is represented as 17 is congruent to 2 modulo 5. 17 is congruent to 2. This symbol here means congruent. 17 is congruent to 2 modulo 5. What this means is that if you divide 17 by 5, you are going to get a remainder of 2. If you divide 2 by 5, you are also going to get a remainder of 2. So that's the meaning of this symbol here, congruency. If you divide 17 by 5, you get a remainder of 2. If you divide 2 by 5, you're also going to get a remainder of 2. Therefore, 17 is congruent to 2 modulo 5. This symbol here means congruent to, and it takes the general form A congruent to B modulus n. A congruent to B modulus n. This means when A and B are divided by n, they give the same remainder. So A congruent to B modulus n means that if you divide A and divide n with the same number n, you get the same remainder. Let's look at an example. "23 is congruent to 3 modulus 10. So this means that if you divide 23 with 10, you are going to get a remainder of 3. And if you divide 10 by 3, you're also going to get a remainder of 3. So that's the meaning of 23 is congruent to 3 modulus 10. Now let's take a look at it. 23 divided by 10 is equal to 2, remainder 3. And 3 divided by 10 is equal to 0, remainder 3. So that is what is represented by 23 is congruent to 3 modulus 10. Look at this example, example 1. Find 29 mod 6. Now this is the same thing as saying find the remainder when 29 is divided by 6. Now, 29 divided by 6 is equal to 4, remainder 5. So when you divide 29 by 6, the result is 4, the remainder is 5. And this can be represented in modular arithmetic as 29 is congruent to 5 modulus 6. So when 29 is divided by 6, the remainder is the same thing as when 29 is divided by 5. So let's check and see if we are correct. 29 divided by 6 is equal to 4, remainder 5. 5 divided by 6 is equal to 0, remainder 5. Therefore, 29 is congruent to 5 when both values are divided by 6. Look at this example. Find 45 mod 8. So find the remainder when 45 is divided by 8. So 45 divided by 8 is equal to 5, remainder 5. So this can be represented as 45 is congruent to 5 modulus 8. So when 8 is used to divide 45 and 5, the remainder is 5. So let's check and see if that is correct. 45 divided by 8 is equal to 5, remainder 5. 5 divided by 8 is equal to 0, remainder 5. Therefore, if you divide 45 and 5 with 8, the remainder is 5. When performing addition operation in modular arithmetic, this rule is applied. If A is congruent to B modulus n and C is congruent to D modulus n, then A plus C modulus B plus D modulus, A plus C is congruent to B plus D modulus n. So what this means is that if we have two values, A is congruent to B modulus n and C is congruent to D modulus n, if we have these two values and we are asked to add them together, what we are going to do is that we are going to add A plus C is congruent to B plus D modulus n. So in this example, we are given two values. 17 is congruent to 2 modulus 5. 13 is congruent to 3 modulus 5. So to solve this problem, we apply this rule. When that rule is applied, the rule of addition of modular arithmetic, 17 is congruent to 2 modulus 5 and 13 is congruent to 3 modulus 5. This becomes 17 plus 13 is congruent to 2 plus 3 modulus 5. This is the same thing as 30 is congruent to 5 modulus 5. This means that 30 when divided by 5, the remainder is the same thing as when 5 is divided by 5. So 30 divided by 5 is 6. The remainder is 0. 5 divided by 5 is 1. The remainder is 0. Therefore, 30 is congruent to 5, modulus 5. Now, but we can still simplify this further. So if we add this value, and then if we simplify, now this becomes 30 modulus 0 mod 5. Or let me put it this way. 30 divided by 5 is equal to 6 remaining 0, remainder 0. So this is represented as 30 is congruent to 0 modulus 5. So this means that 30 divided by 5, the remainder is 0. 0 divided by 5, the remainder is also 0. Therefore, 30 is congruent to 0 when both numbers are divided by 5. Look at this example on the board. This is subtraction of modular arithmetic. So the question says we should subtract 7 from the first value. 19 is congruent to 4 modulus 5. So let 19 is congruent to 4 modulus 5 be the first value. So we are going to subtract 7 from it. To do that, the first thing we need to do, we need to find 7 modulus 5. So we divide 7 by 5 to get the remainder. Now, this is 7 divided by 5, which is equal to 1, remainder 2. And this is represented as 7 is congruent to 2 modulus 5. So when 7 is divided by 5, the remainder is 2. So it's congruent to 4 when it is divided by 5. That's the first value. The second value, 7 is congruent to 2 when it is divided by 5 as well. So, I'm going to subtract these two values. So this becomes 19 congruent to 4 modulus 5. 7 is congruent to 2 modulus 5. To subtract the second value from the first value, this is what I'm going to do. 19 minus 7 is congruent to 4 minus 2 mod 5. So I'm applying the same rule for addition, but in this case, I'm subtracting instead of adding. So this becomes 12 is congruent to 2 modulus 5. So this is the answer. We are given two values here, 12 and 7. 12 multiplied by 7, modulus 5. We are asked to simplify this expression, 12 multiplied by 7, modulus 5. So how do we go about this? The first thing we are going to do is to reduce this expression, then we will now multiply the results. So this is the same thing as, if I'm reducing this expression, I'm going to do this. I'll find 12 modulus 5 and 7 modulus 5. So if I do this, this is going to give me 12 divided by 5 is equal to 2 remainder 2, and 7 divided by 5 is equal to 1 remainder 2. Now these two expressions can be expressed as 12 is congruent to 2 when it is divided by 5. As the first expression. Second expression, 7 is congruent to 5. 7 is congruent to the remainder 2 when it is divided by 5 as well. Now these two expressions, we're going to multiply both of them together. Now this becomes 12 multiplied by 7 is congruent to 2 multiplied by 2 mod 5. So this is how to perform multiplication in modular arithmetic. 84 is congruent to 4 mod 5. So this is the answer. Find the remainder when 73 is divided by 9. Solution. (73) divided by 9 is equal to 8 remainder 1. Therefore, this is expressed as 73 is congruent to 1 modulus 9. So, find the remainder when 73 is divided by 9, the remainder is 1. And 73 is congruent to 1 mod 9 because when 9 is divided by 73, the remainder is 1. When 1 is divided by 9, the remainder is also 1. Evaluate 28 plus 35 mod 6. Now, if we come across this type of question, the first thing we are going to do, we look for the remainder of each of the values in the expression that we are asked to evaluate. So here we have 28 plus 35 mod 6. So the first thing we need to do is look for the remainder of these two values. So 28 divided by 6 is equal to 4, and the remainder is 4. 35 divided by 6 is equal to 5, and the remainder is 5. So these two expressions can be expressed as 28 is congruent to 4 when it is divided by 6, and 35 is congruent to 5 when it is also divided by 6. Now, to evaluate this expression, we are going to add these two values together. So when we add these two values, it becomes 28 plus 35 is congruent to 4 plus 5 mod 6. So this is the same thing as 63 is congruent to 9 mod 6. We can simplify this to 63 is congruent to 3 mod 6. In this question, we are asked to evaluate 16 multiplied by 9 mod 7. 16 multiplied by 9 mod 7. Now, we're still going to apply the same method we used in the previous question. We are going to find the remainder of these two values. We'll look for the remainder of these two values. Then we will now multiply both expressions. So this is the same thing as 16 divided by 7 is equal to 2 remainder 2. 9 divided by 7 is equal to 1 remainder 2. So this can be written as 16 is congruent to 2 modulo 7, and 9 is congruent to 2 modulo 7. So now we can multiply these two expressions. So when these two expressions are multiplied, 16 multiplied by 9 is congruent to 2 multiplied by 2 mod 7. Now this is the same thing as 144 mod is congruent to 4 mod 7. If you follow this video to the end, do these practice questions. If you did not understand the video, you can go back and rewatch the video and then attempt these questions, these practice questions. I want you to do these questions for me from number 1 to 4. Find 41 mod 7. That's question 1. Question 2. Evaluate 25 plus 18 mod 6. Number 3. Evaluate 14 multiplied by 11 mod 5. Number 4. Express 32 is congruent to question mark. There's a value here that is not here, so you're supposed to put this value mod 9. I want to see your answers to these 4 questions. Post your answers in the comment section. I want to see them.